Hello, everyone. Thank you for joining us today. I am Anushka, Senior Research Associate in the Agri-Tech area of expertise at BIS Research. It is my honor to present to you today's webinar, LoRaWAN, a new age of agricultural IoT in association with World Agri-Tech Summit. BIS Research has been tracking the LoRaWAN network technology since the past 4 years. LoRaWAN, Long Range Wide Area Network, is a technology that can be used to monitor farm assets as well as crop and livestock conditions. This technology is an example of the IoT or smart farming in agriculture. Agricultural companies and farmers can use data collected through IoT to make management decisions. Farmers can use this technology to install small sensor devices in their crop fields to monitor conditions such as rainfall, soil moisture, and temperature. For today's discussion, we have an esteemed list of guests. To start with, first of all, we have our guest, Mr. Marco Brini, who is the Digital Agriculture Expert, World Food System Center, ETH Zurich. He has 20 plus years of experience in leveraging digital innovations to the benefit of the market. And also, he co-founded 3 companies. Next, we have our second guest speaker, Mr. Paul Pinault, VP, IIoT Product and Market Strategy at BrainQ. Paul Pinault is the owner of Disk91.com and a content writer on IoT and IIoT technologies. He has been a part of Sigfox, the Things Network, Helium ecosystems since the early days and investigates a lot on satellite IoT. Alongside Marco and Paul, we have our in-house experts, Haritha Surendran, who is the lead analyst of the Agritech area of expertise at BIS Research and a keen Agritech enthusiast. She has a wonderful track record of executing custom projects focused on cutting-edge deep tech topics for the agri-tech sector and providing strategic solutions to numerous high-profile clients. Then comes Pritha Kole, Senior Research Associate of Agri-Tech Domain at BIS Research Analysis. She has authored multiple market intelligence reports in the agri-tech area and has been widely commended by various industry opinion leaders for her incisive analysis and recommendation. The agenda for today's meeting is as follows, wherein we'll be first of all discussing the current needs in agriculture sector, then LoRaWAN in agricultural applications, followed by the presentations of our key speakers, Mr. Marco Brini and Mr. Paul Pinault, then adoption scenario of LoRaWAN technology, conclusion and future outlook, followed by the Q&A session. I thank all the panelists for their gracious presence. A very warm welcome to all of you. In the next 1 hour, we are all keen to learn from your experience about LoRaWAN and its current state in agriculture industry. And towards the end of the discussion, I will be opening the panel to the audience for any questions. We would try to answer as many questions as follows in the given time frame. Any questions that we are not able to answer today shall be reverted later on through email or a dedicated blog post. Having said that, let me open this panel for discussion and invite thoughts from Haritha. Over to you, Haritha.
Thank you for the thoughtful introduction, Anushka. So I would like to extend a warm welcome to the audience and the guest speakers. Thank you for being here today. So I would like to start by discussing the key current needs of agriculture sector obtained by BIS research. So the United Nations estimated that the world population will increase by 49% from its current level to 9 billion by the year 2050. So the demand for food is expected to double in the coming years due to the growing population. And food supply has become a threat to this growing population. On the other hand, if you see, due to industrialization and urbanization, the arable land in the major agriculture countries is declining. As per the FAO forecast to 2050, only 12% of global agriculture land surface is used for crop protection, and there is little scope for future expansion of agriculture land. And in addition, FAO also estimated that annually up to 40% of global crop production is lost to pests. So as per the World Bank data, the percentage of employment in agriculture has decreased by around 13% during the last decades. The firm's operating expenses are associated with the cost of fertilizer, labor charges, pesticides, seeds, and other supplies used in production. So according to USDA, agricultural production cost increased by around 11% in 2022, and it is likely to increase by 1.3% in 2023. The agriculture sector is directly responsible for 12% of global greenhouse gas emission, mostly due to the methane emissions from livestock and rice, and from nitrous oxide emission from fertilizer. So, being the largest water consuming sector, it can harm biodiversity and reduce water quality from the runoff of fertilizer, pesticides, and manure. So, how the farmers in agriculture sectors are addressing the issues we discussed so far? The one way is by producing more with limited resources to meet the food demand for growing population, and focus on optimizing the agriculture input because farmland yield differently in different part of the field due to soil heterogeneity. The farmers require real-time data about the diversity within the field to properly apply input to fulfill the plant demand and require and to reduce production cost. As a result, there has been a greater emphasis on selecting network technology for IoT devices used in the field to support in timely data exchange at higher speed and lower cost. Next slide, please. LoRaWAN. So, LoRaWAN protocol is a universally accepted network technology that provides long range up to 15 kilometers and bidirectional communication and ensures interoperability between all LoRaWAN network as it is based on open protocol approach. And LoRaWAN uses unlicensed ISM radio bandwidth for low cost network of deployment. So, based on BIS research estimates, it shows that global digitalist acreage is just 11% of total utilized agricultural land. However, the precision agriculture market is expected to grow at a CAGR of 14% in the next 5 years. And precision farming is entirely dependent on connectivity as well. It does not require high data rates or the low latency communication that faster cellular network can offer. The sensor typically communicates small packets of data every few hours with simple messages such as percentage moisture level, temperature level, and others. So we can say that LoRaWAN is the best network or best suited for precision agriculture because of the low cost of data transmission at very low power with sensors having a battery life up to 15 years and which enabling the farmers to scale their deployment and benefit from the two operational visibility. Also, the farmers will incur less maintenance and operating expenses as a result of limited operator intervention. Next slide, please. A single LoRaWAN gateway can connect various kinds of LoRaWAN sensors in difficult and remote environment and can serve up to the needs of an entire farm. The key applications of LoRaWAN in agriculture are for irrigation, more accurate information for fertigation and irrigation decisions, and for monitoring beehives even in remote areas. Data can be collected using a hybrid sensor and sensors to satellite LoRaWAN solution. The farmers can analyze the relationship between weather station data and seed drying process operation during a LoRaWAN weather station in real time to avoid over and under drying and maximize equipment efficiency. So LoRaWAN connectivity broadens the network coverage area for large livestock farms and enabling them to identify the precise location of roaming cattle. And LoRaWAN long-range coverage of large farms enables monitoring of farm vehicles and enabling performance optimization and cost saving on fuel, oil, operation, and application times. I think that covers my part. Over to you, Anushka.
Thank you for such great insights on the introduction of LoRaWAN, Harita. Now, I would like to call upon our next guest, that is Paul, to speak up further on the topic. Over to you, Paul.
Yeah, thank you. I was expecting the other speaker to start. So, hello to everyone. Happy that you joined the webinar, and I'm going a bit deeper on the LoRaWAN technologies to better understanding why this technology is really interesting in the agricultural domain. Just a point of definition, we are talking about LoRaWAN, which is a slight difference compared to LoRa. And just to make sure you got this, LoRa is a technology, it's a radio technology, it's a point-to-point technologies, which is a really interesting characteristic we're going to see. And LoRaWAN is a protocol over this LoRa technology, allowing to make LoRa a network. So LoRaWAN is open source in some way. This protocol is open and there is many implementation, but LoRa is a technology that is owned by Semtech and which is a proprietary technology. Even if you have different funders that are providing this technology, like ST Microelectronics and Semtech currently. We can go to the next slide, please. So to better understanding why we are talking about LoRaWAN and why this has been something really interesting, and particularly in the agricultural domain, is because LoRaWAN is part of what we call the LP1, which are the low power and wide area network. And this is quite interesting because before Sigfox and LoRaWAN invent this LP1 domain, if you wanted to reach a long distance and have a large coverage to cover areas like in agriculture, you had a need to use a lot of power in devices. And using a lot of power means one thing: having a source of energy or having large battery, and basically it makes it expensive to produce or expensive to maintain, as you have to change this power source on a regular basis. So the low power wide area network means that with a really low level of power, you can achieve a really long distance. And so that's a revolution, by the way, but it means that with a small cell, you can have a device that is reporting data for years. And so basically, you can produce a device which has a really limited cost and with a really small maintenance cost, which is really, really important. We can go to the next slide to see what the advantage of such technology. It basically allows to have device cost which is really reduced. And when I say reduced, we have application with Sigfox, for example, which is under $1. And for LoRaWAN, we have application under $5 per devices, which is really low cost. It means that you can eventually destroy your device after a short duration, and it makes it a viable use case at the end. So low-cost device, having networks that are really long distance also means that the network cost will be low. So you won't have a lot of base station, gateways, or you name it as you want, but the network infrastructure cost will be really low because you don't need a lot of them. You can have a really long autonomy, and as I explained, it's really a key element in agricultural environment, as you don't want to change the battery of thousands of devices spread over a large territory. It really simplifies the user setup. It's really reduce the battery size, and basically it's also breaks the boundaries. I mean, there's no telecom operator and nationwide for this. It's more global things, and that's also a way to really simplify things. Even if in LoRaWAN, especially, we are usually seeing most private networks. We will see this later. We can go to the next slide, please. So we envision LoRaWAN as grown network, but just to tell you that LoRaWAN is not just grown. There are different actors of satellites IoT that are quite interesting also in agricultural environment, particularly when you are in a really wide areas. And as part of this, you have Lacuna Space, which has been a pioneer in doing LoRaWAN from space, but you also have other participants like Eutelsat that should propose soon some services around this. And multiple of them are arriving. So I know three different satellite operators that are going to provide LoRaWAN coverage. What is quite interesting in that situation is that you can easily imagine some devices that will have a ground communication, but can switch to a satellite communication with a lower rate and things like this when it's basically needed. We can go to the next slide. In terms of technology, what makes LoRa communication a bit special is the way basically the 0 and 1 are encoded. And that's the reason why we have really long distance with low power. And where we are talking about long distance in LoRaWAN, we are talking about 10 to 80 kilometers. That's the long distance by LoRaWAN. Usually 10, 20 is a good range. And in terms of power, we are talking about 25 milliwatts in Europe, a bit more when we are in the USA or in Asia. But to give a comparison, Wi-Fi communication is about 100 milliwatts or more to cover 15 to 30 meters. So here we are 25 milliwatt to cover 20 kilometers. So that's really the highly raw number you need to have in mind. So how does that work? In fact, the communication, the bits are encoded with frequency variation. So basically what you see in red on this slide, it's the movement of the signal over the frequency. And we can simplify this by saying when it goes from left to right, it's a 0, and when it goes from right to left, it's a 1. It's a bit more complicated like this, but that's the idea you have. What is really interesting with this is that even if you have a jamming in the middle of the communication, the jamming is usually at one specific frequency, and basically the signal will still be visible as the direction of the signal will be able to be decoded even if a part has been jammed in the middle. And thanks to this, this modulation is propagated on really long distance, and you can have a really high sensibility for receiving this signal, and you can cover really long distance with low power. That's the magic of this technology. We can go to the next slide, please. So there are some consequences. Basically, this technology is low power. This technology is using free frequency, so the ISM bands. So basically, you can deploy it without having a special authorization to use the frequency, which helps to deploy it in private environment and at low cost. But as it's an ISM band, you have some regulation rule to be respected. And as part of this regulation rule, when you are in Europe and Africa, you have what we call a duty cycle, so a limitation of transmission time. When you are in other zone like Asia or America, you have a channel hopping system. So you can talk quite every second if you want, but you have some constraint to respect in terms of channel hopping, and usually it comes to a certain level of duty cycle at the end. So the quantity of message you can transmit is limited, and also the speed of the transmission is limited. The speed of transmission is limited by also the ability to cover long distance. So that's a consequence. In fact, if you ever want to cover long distance with such solution, you have to have a low speed communication. And what low speed communication means for LoRaWAN is 250 bits per second for the lower speed to 5.4 kilobits per second for the higher speed. So it's really a low speed communication compared to 3GPP technologies. But thanks to that, you have the energy saving and the really long distance. So to give you an idea to communicate 10 bytes of data, it goes from 56 milliseconds at the high speed to 1.4 seconds at the low speed. And for sure, if you use the lowest speed, the distance and the quality of the signal will be really higher than if you go to high speed. Basically, to give you an idea, if you go high speed, the coverage is more about 10 kilometers. And if you go low speed, the coverage can be up to 20 or 40 kilometers. We also have good results at 80 kilometers, but I won't recommend to consider that it is a stable communication. What does that mean regarding the speed of transmission and the duty cycle rules you have, particularly in Europe? It means that the number of messages you can transmit is constrained. And for example, in Europe, if you go low speed, it's a maximum of 6 messages per 15 minutes. But if you go high speed, it's really more high level, as you can have 162 messages per 15 minutes. Now, that's the maximum you can get, but what you have to know is when you go to LP1, what we want is devices that are autonomous, that can live for years in a field with small batteries, and basically we are more about transmitting a message every hour or every 2 hours or every day, more than every second. Because what we want is to preserve the battery, and if we transfer 162 messages per 15 minutes, even if it's low energy communication, at the end the battery will drop quickly and the maintenance cost will be high. So we are more using this like for 1 hour basis or one every 30 minutes basis communication with small frame like 10 bytes or 20 bytes. And that's really where this technology is really fitting really well. We can go to the next slide. So in terms of architecture, we have devices, and the devices are communicating with gateways. So gateways are basically the antennas that are getting the messages. There's no specific association between device and gateways. So all the gateways in the area will receive the message from the device, which is quite interesting for localization application. And the gateways are reporting these messages as data to what we call a LNS, which is a LoRaWAN network server. And the LoRaWAN network server is basically managing the writes on devices, is filtering the traffic, and then extracting the data and pushing the data to an application server. The LoRaWAN network server can be a private server, or it can be a public server. You have different instantiation. So you can have public LoRaWAN network server provided by telecom operator. You have LoRaWAN network server provided by community, and you can have your private LoRaWAN network server to manage your own devices. At the end, the data are pushed to a customer application. So basically the industrial application you want to have. And this application is managing the data, extracting the value from the data, and providing the service to the end user at the end. Can you go to the next slide? The last point, which is interesting about this technology, is we have different class of communication for the devices. This network is a bidirectional network, so you can have devices communicating to the LoRa network server, but you can also have the LoRa network server communicating to the devices. So we can report data, which is the main purpose, but we can also have an action from the device to its environment. In class A, this communication, downlink communication, so network to device, is managed just right after an uplink, which basically means that there is no power that is consumed for receiving. It's just after an uplink that you have a short window of reception where you are expecting messages. The B class is a class where you have scheduled downlink. So basically, you configure reception windows, and the device will automatically switch in reception during this window and try to get information from the network. This kind of application is more consuming energy in terms of energy for reception, but it's quite efficient because you have this Windows that is negotiated with the LoRa network server, and you just listening, receiving during a short period of time. The class C is a class where you are in continuous reception, which basically means you are consuming a lot of power for the reception, and it's not really fitting with devices that have a battery inside or it's a big battery, because the reception will be something like 15, 20 milliampere per hour, which at the end of the year is a lot of energy. But the advantages of this class C is that your device can receive a message at any time, and you can have a real-time communication and interaction between the device and its environment. Most of the implementation are class A for the devices up to now. You can go to the next slide. So let's see in practice what does that mean in an agricultural environment. So this is some experience I've conducted, I think like 4 or 5 years ago at the beginning of LoRaWAN, by placing one device, one gateway on an agricultural exploitation, which is basically where you see the arrow here, the black arrow, just at the beginning of it. It's where the antenna has been placed. And what you see in blue here is the agricultural exploitation. And what you see in green is basically the coverage of this gateway. To give you an idea, this kind of gateway at this 5 years ago was about $1,000. Now, same gateway for same result would be something like $200. So it's really a low-cost investment. And all the points you see are tracking reports. So we put a tracker in the agricultural equipment. And so the farmers, by going and walking, have taken the coverage information. And so what we see basically is that the blue part, which is the exploitation, is covered by 80% with a single gateway. And anywhere in this exploitation, we were able to connect different devices for reporting information. This is a co-exploitation, so it's quite extensive, and there is a lot of application about the health, about the monitoring of fencing monitoring, about water tank level. I mean, we have plenty of application behind this. As you can see, some part of this enterprise is not covered. I mean, here it's an area where there are a lot of mountain. So you need to understand that this technology is not passing through the mountain. So if you have a flat area, you can have a really, really large coverage. If you are in a mountain and valley, you will have to use more gateway to cover the entire zone. We can go to the next slide. So this was a private environment. So we deployed a specific gateway for covering the farming exploitation. But we also have other solution. If you don't want to manage your own LoRa network server, you can rely on community-like network server. And there is different community networks that has been built. The first one was ZSync network, which is attached to the ZSync industry, which is providing professional service on the ZSync network. It's what we call a crowdfund network, which means that any of us can add gateways and join this global network. That way, we get benefits of a global LoRa network server just by adding our gateway to the network. And the other advantages is that you're getting benefits from gateways that has been deployed by neighborhood. So this is basically creating a big network. So that's an option different than having a private network. And you also have public networks, but you may know that public networks in LoRaWAN are really, really limited. Not a lot of telecom operators are providing coverage. So that's why the crowdsourced solution are really good option to take a look. We can go to the next slide. So the ZSync network has been created in 2015. So just to give you an idea, the specification of LoRaWAN has been in 2016, so they were really early adopter. And basically, there is 30,000 gateways deployed in 150 countries. And I mean, I should have update my numbers, but yesterday they announced 1 million devices running on the stack industry environment. So it's basically a good number of devices with a lot of professional implementation, a lot of smart city application, for example. And the footprint is mostly in Europe currently. We can go to the next slide. And which is about another option, which is newer and also really interesting. It's the largest LoRaWAN network that exists worldwide. It's Helium. Helium is like the SIM network, so it's a crowdfunding network that anyone can contribute to and extend. The difference is Helium has been powered by a cryptocurrency. And I mean, even if people don't really like cryptocurrency, it has been an accelerator for such deployment. And if we go to the next slide, we will see that this network is about 1 million gateways that has been deployed up to now. So 1 million gateway is far different compared to the 30K we've seen previously on the SIM network. So that's really interesting, as Helium has a really strong coverage in North America, a really strong coverage in Europe, and particularly in Northern Europe and Eastern Europe. Portugal also is really well covered. And we see a good coverage also in ASEAN area. So this network is, powered by blockchain, but you don't need any crypto to use it. It's a network you can use with, standard, like a public operator when you can buy your communications on it. The main difference compared to classical operator that the price is something like 10 to 50 less than the price for classical operator. So basically, it means that running a device for your on a such network is under a single dollar, usually. Can be up to 10 cents a year, depending on the traffic you have. And that's really interesting because you don't have to manage the LoRa network server. You get benefits of the million of hotspots that are already deployed, and you access it for really low cost. So that's good option. And you can improve it by adding your own hotspot on it for sure. We can go to the next slide. So concretely, I'm living around this area, and so basically what you see on the left part is so the area where I'm living. It's basically 100 kilometers or 60 miles from north to south, and we have about 200 hotspots that are deployed, or gateways that are deployed in this area. And what you see in red is a really big farming area we have around us, which is a bit famous in Europe. It's a farming area 100 kilometers long. And basically all this area is covered by the Helium network, which basically means if there is some agricultural application in this area, the network is already deployed and can be used. And what I mean by this is that, in fact, it's really something interesting to see what kind of network exists in the area where you have application, because you have a chance that already a network like the SIM network or Helium is already there. And so the cost to deploy and secure the coverage is really low. And so you can directly deploy your sensor with a really low investment into the infrastructure, which is quite important. In this area and around, I've tested different use cases, which are really interesting in agricultural. Code tracking, for example, it's quite interesting to see the activities, to measure the health, to see the position, to find them when you're in extensive management. We had a really great use case on fence monitoring, as it was one big pain for farmers. We had also a lot of interesting things around weather and the ability to deploy weather station on many different places where connectivity is usually complex to get really precise weather forecast, for example. There is a lot of application in a smart home or smart building with building security and monitoring, and a lot of things to do around asset tracking and equipment, because a lot of agricultural equipment are shared between farmers, and having an ability to track them. Also for all the application in traceability, we had a really interesting things. We also had water tank level monitoring with the dry period we had this summer. That was something really useful for farmers. So there is plenty of use cases you can imagine. So once you have the network, a sensor is usually something around from $25 to $100, and the connectivity, as we have seen, can be really low, like $1 a year. So there is a lot of business model that can be deployed with a return for investment, which is quite fast. I think I arrived to my last slide.
Thank you, Paul, for your detailed insights on LoRaWAN network architecture and also the various applications in the agriculture zone. Now I would like to call upon Marco to discuss the topic further.
This is really giving everyone quite an understanding of what is LoRa. And now we'll see why LoRa. So basically, we want to collect data from the farms. And we have now wonderful sensors that are talking, machines that are talking, and how to collect all these data in an easy way. So it's like the highway. It's hard to have nice cars to be used conveniently if you don't have a highway. So let's go to the next slide and see, trying to understand how the IoT industry is facing this problem. I've been there, and I've been there since 2005 in the IoT industry. And the main problem was not capturing the data with a sensor, but really moving this data out of the field. In the farm, you don't have cable. In the industry, in the manufacturing, you can put cable everywhere, and therefore IoT is not at all a novelty. IoT in the manufacturing sector is there for 40, 50 years. There are a lot of protocols, but in the agriculture, you cannot put cables into the field. This is really a no-go. And so you need something that is bringing these data out to the internet to use them. And so this is normally the role of the gateway. The gateway is an additional tool that you put there only for the purpose of getting this data from the sensor and bringing this data to the cloud. Now, the gateway is the most expensive, is the most complex, and therefore the one who has the highest probability to crash. And I have installed sensors in the desert, in high mountains, in the forest, in any possible place, in the glaciers. Always the gateway was the problem, never the sensor. So we want to get rid of these gateways. So let's go to the next slide. This is what we want. We want a world without a gateway. It's like when you are calling, when you have your mobile phone, right? And you're making a call. You want to have your mobile phone to call. You don't want to bring with you the tower, the communication tower that telco put, and everyone hates, but everyone uses. You want just to have your mobile phone and talk. And This is what the Internet of Things industry, and in special case, the farming industry, want. They want someone else to take care of the communication and just focusing on getting the data and using the data. Next slide. So Paul already was very, very clear and generous with information. So just to sum up, I believe from the Paul presentation is pretty clear that LoRa comes at a price. And the price is, it's not fast. But the point is, who cares? Because the sensors, they don't need a lot of data to communicate. They are not like us that make sounds that needs to be then decoded. So the mobile phone network was conceived to deliver the sound of our voice back and forth, and then we understand. But the sensor, they would just communicate few numbers, very few in the case of agriculture. And therefore, it's a good trade-off to really have a slower network. In exchange, we get low power and long distance. Why are low power and long distance so important? Because we don't want to go in the field and change the battery of our sensors, because this is time consuming. We don't want to ask additional time to the farmer. We want to help them to save their time. We don't want to buy a lot of batteries, going there, opening the sensor and changing the sensor. And so to have sensors that have a long life, we want to have a network that is consuming as little as possible. And the only thing we are going to ask to our sensor is, don't talk too much, please. And normally they don't care, because in the agriculture, normally if you get one data per hour, this is already a good thing, because normally the weather station are sending data every day, right? So every hour it's already been rich of data. And more data, what's the point? The soil humidity of the soil, it doesn't really change so fast. Therefore, in short, LoRa is getting rid of the gateway, focusing on the sensor. The sensor will have longer life and will communicate to long distance, which means the entire network is lighter. Less gateway will be required. Next slide. Two examples. So adding to what Paul explained as options, if you live in Switzerland or you live in Netherlands, the entire are almost entirely covered. And this is quite relevant for Netherlands, what I would say is entirely covered. So any farmer can buy a sensor, place a sensor in the field, and would just connect to the network, to the public operation network. In Switzerland, it's trickier. It's extremely interesting because Switzerland is a lot of mountains. And indeed, if you look at the map, you will see that the northern part and the very south part, where less mountains are present, are, let's say, fully covered. While in really where Alps are really high, there you have less coverage, but you also have less agriculture. So there is no problem. And 5 years ago, I've been setting up with another startup in Basel a new type of sensor that is making use of LoRa. We tested that there was no need to place any gateway. Any place you were putting the sensor was just working. So that is basically as if your plants are using the mobile phone. There is no need to additional network. We have been doing installation in Brazil and in other areas. There you need to buy a gateway. You'll buy a LoRa gateway that, as Paul explained, can cover a very large area. And so you save a lot of money anyway. In addition, you can put the gateway far away, for instance, in a place which is enclosed, where you can have power easier. Next slide. So this is LoRa Alliance. LoRa Alliance is trying to push LoRa and so involve more and more telco into giving a public services. And of course, all other initiatives are very welcome. But if you can, like in Switzerland, in Netherlands, just plug your sensor and not think to anything, that is great. Next slide. Okay, so these are some example of the sensor that you may be willing to make use of. Soil moisture sensor are number one. Then weather station sensor, it means temperature, air, relative humidity, solar radiation. You can have and sometimes wind, pressure, very very rarely. Then you have other type of sensor. You can have sensor on the livestock as well. And the smart irrigation system, it is extremely interesting, can be combined with a drip irrigation system and save a lot of water, which means a lot of energy and a lot of time while making the plants happier. Next slide. These are some of the provider. So you can see, of course, it's not the entire value chain of LoRa, but on the left you can see the module providers. Some of the module provider you can buy, integrate these, and then you can have your sensors, which is equipped with the LoRa transmitter. And then finally, on the right, you see some of the operators in Switzerland. For instance, you have a Swisscom, KPN in Netherlands, and so on and so forth. Next slide. Okay, here is a hypothetical use case. So someone may say, okay, let's think about India. It's a huge country, right? It's a country of countries, actually, as we know. So it must be extremely expensive to fully cover that with LoRa. So if we keep for a second aside the Himalaya region and where you have high mountains, like in the Switzerland case, and you focus, let's say, only on the agricultural area, what has been disclosed as the agricultural area, which is around 1.4 million kilometers square, according to FAO. Yeah, I made some calculation for a rough estimation, and you will need about 12,000 gateways, probably less, and they will cover 120 million agri-sensor. It's a lot, and the total cost will be around 36 million US dollar. Like Paul mentioned, 1,000 per gateway. It's been generous. So now you can find with less. But let's say you want to have rough gateway, robots, and so on. Then let's have an installation cost of 2,000 US dollar per each, leveraging existing places and eventually cooperating with the local communities that will benefit of that. You see, the cost is really ridiculous. And you need to add only, of course, the project management cost, you set it up and everything, and the overhead, plus all the servers that will need to, you will need those servers to collect this data and then to share this data, but it's not rocket science. So this is not the final cost, but all the raw cost of raw material. Next slide. All right, this is the last slide, and it's probably unnecessary as Paul was very, very extremely clear. Basically gives you, again, a few additional information, a few technical information, but I believe we covered the entire story thanks to the Paul presentation. So I'm over and leaving space for the next session.
Thank you, Marco, for shedding some light on the cost structures, complexities, and benefits of LoRaWAN. Now I would like to call upon Pritha to discuss more on the topic.
Thank you, Anushka. The key stakeholders in this market are categorized into 5 different types of companies. Technology companies are the ones that develop and manufacture hardware and software components. So let's just say, for example, Semtech, Actility, and Curlink. The infrastructure required for the deployment of LoRaWAN networks, such as gateways, include companies such as the Things Network, Senet, and KPN. Companies that have incorporated LoRaWAN equipments, for example, sensors, are companies such as Valmont and John Deere. Next slide. Some major active players are Senet, Curlink, Semtech, IMST, and Actility, among many others. For instance, in March 2022, Senet and Grid Technologies launched LoRaWAN IoT connectivity to Ohio River Valley. One use case example for LoRaWAN based sensor network application is that Curlink implemented a LoRaWAN based sensor network for precision farming, and this network was used to monitor a vineyard's soil moisture and similar conditions like temperature. Next slide. As per the table shown on the right side, 5G IoT has the highest CAGR, which is cumulative annual growth rate. Thus, more focus on data security and operator willingness is required to invest in the LoRaWAN network. This will further boost the market. Sigfox is present in 75 countries with approximately 16.3 million devices, which is far less than 5% cellular IoT devices installed for agricultural applications. A few areas where LoRaWAN technology requires development are logistics, facilities management. Currently, the utilization of LoRaWAN technology in exchanging farming sector sensor data is very low, and some of the factors are, if we talk about topographically, the remoteness of farms can make it challenging to provide coverage for LoRaWAN. Next slide. Many agricultural areas do not have access to reliable power sources. If we talk about environmental challenges, extreme temperatures, humidity, these can damage the lifespan of LoRaWAN. Competitive barriers such as the devices and the equipments, those can have a potential interference which can make LoRaWAN devices less reliable. Monetarily speaking, implementing a LoRaWAN network in an agricultural environment can be high, and the return on investment can be very uncertain. And with respect to regulations, there's a lack of standardization, and talking about the complexity, the need for high technical expertise further acts as a barrier. So these were some of the challenges for the LoRaWAN technology. Now here we have some key takeaways. The Netherlands was the first country to have LoRa IoT network in 2016. Currently, there are 181 networks operators globally. Talking about the adoption, LoRaWAN technology has experienced 3 times more increase in as compared to 5G technology, and LoRaWAN is expected to grow at a robust rate of 45% in the next 5 years, and it has more than 225 million end nodes, and these networks are available worldwide. Now I will request Anushka to take over from here.
Thank you, Pritha, for the insights on the topic and for also explaining the challenges and future potential of LoRaWAN in the agriculture sector. As you can see on just As you can see on the screen, a lot of our research studies are focused on emerging technologies, including AI, IoT, AI, and blockchain. Some of our ongoing reports include agri-sensors, precision pest management, agriculture technology as a service. Some of the published reports include smart harvest market, precision irrigation, smart vineyard management, and others. If anyone is interested in gaining more about any of these studies, you may tell us in the chat and our team will reach out to you soon. We at BIS Research are developing what we are calling the Deep Tech Technology Knowledge Platform, where we are trying to integrate with industry experts from different markets, different industries, and different regions to come together on a network platform where they can connect with each other, ask questions, and answer questions free of cost. This is all about free, and you will be able to be a part of industry experts. You can also share your questions and get multiple answers to them. It is more of an expert-oriented knowledge sharing session platform. That's what our vision is for Insight Monk. You can also get multiple collated reports and research papers to provide you more solutions. If you have any questions or are interested in knowing more about this platform, you may tell us in the chat. Thank you, Marco, Paul, Harita, and Pritha for discussing the role of LoRaWAN in agriculture so illustratively. LoRaWAN is one of the best suitable technology for precision agriculture because of its simplicity in deployment, capacity that is more than adequate for farming applications, and ability to cover large geographic areas. The idea of applications that aggregate data from various devices all connected over LoRaWAN is becoming a reality, thanks to the ongoing maturation of the ever-expanding LoRaWAN ecosystem of developers. With that thought, let me conclude today's session, and now I declare the forum open for any questions from the listeners. I request the listeners to kindly type the questions in the chat box or through the QA forum, and I'll be happy to pass the questions to the esteemed speakers today. So we have a question from the audience, which is there connection issues with hillsides and direction or problems with buried sensors? I would request Paul to take up this, please. Marco, would you please be?
I can take it, yes.
Yeah.
I can take it if there's problem. Sure, Paul, by the way, said it. I mean, this is physics. The electromagnetic wave cannot go through a certain amount of rocks and earth. So where you have a hilly area, well, you just place the gateway on top of the hill, and then it will most probably cover all the entire area. So where you have a problem, you also have an opportunity. I personally done several installations in the valleys, and so you identify a convenient place on the mountain, and then you clearly see where your eyes see the gateway, the communication will be functioning.
Right. We have another question from the audience, which is about yeah. So it's about what is the cost associated with implementing LoRaWAN technology on an acre of farmland?
It's much less than anything else, basically. So it depends. So you'll buy a sensor. It's a very good question because we need to put ourselves in the shoes of the farmer. We want to make the farmer happy. They will make us happy, making better food. So if you buy a sensor and it's LoRa based and the area is equipped with LoRa, you need just to buy the sensor. And normally the sensor is 1/10 of the cost of the gateway. If you don't have LoRa and you need to have a gateway, then you need to buy the sensor and the gateway. So let's make an example, standard. Let's say that you need to have 3 soil sensors and you want them to communicate. 3 soil sensors will, let's say, will be $300, 100 each. Do you have a gateway? No. Then you need to buy a gateway, which is an additional 1,000. So you'll have 1,300. Do you have LoRa? Yes. These are LoRa ready sensor? Yes. Total cost $300. I hope I answered.
Okay, so we have one last question for the session. That is, what is the difference in complexity in installing LoRaWAN technology on a small and a large farm?
No difference. Short answer.
And we also have this interesting question, which is about, for Indian scenario in farms, how can sensors be connected in 5 kilometer square farm? Can one or two gateways be used?
Yes, there was the answer also for Paul, which I completely agree with. Always use two, because you want to have redundancy. You don't want to miss data. Gateway is the most sensitive part. If you need to install a gateway because there is no service of LoRa, buy two. Okay, it's 2,000 instead of 1,000. You are not gonna regret it, because the gateway is the most sensitive part, is the most subject to any type of problem. You may have some interference, so when one gateway is not getting the signal, the other will certainly receive that. One gateway will probably be enough. The area is absolute. If it's, of course, even if it's a linear 5 kilometers square, the gateway, they can go up to more than 100 kilometers in an ideal condition. So one will be enough, but by two.
One last question that we have coming over is about, what about the reverse sending an instruction to a specific device to actuate an order? Is that easy to implement?
Excellent question. This is under the bidirectional specification of LoRa. Bidirectional, it means that not only LoRa listen, but LoRa can also talk. And so the answer is yes, indeed. Thank you, Leone, for the question. Indeed, the smart irrigation systems are among the probably I wouldn't say the only, but among the most of the sensors are the one that make more use of this bidirectional communication. What does it mean? It means that the question means the following. I am a farmer. I am setting up an automatic irrigation system. I have, let's say, a long drip irrigation system. Every valve is controlled by a sensor, so by an actuator. I have a sensor that will tell me, there is not enough humidity, so I need to irrigate. And this will automatically close the loop. But what if I want to change the pattern? What if I want to say, at this point, I want my plant to have some hydric stress, or I want the plant to have some more water because I won't push a behavior on them. Or I know that we are getting rain in a short time, so there is no need I'm going to irrigate. How are you going to communicate this information to the sensor? You need a bidirectional unit. And LoRa allows this communication to happen. And it's not particularly complicated to make. Once someone is able to work with the LoRa protocol, then it will be easily able also to implement this functionality.
So in the interest of time, we would have to hold this question and answer session for now. Meanwhile, you can still post your questions or mail your questions to us on hello@bisresearch.com. With the help of our speakers and analysts at BIS Research, we'll try to answer these questions and send it across via email or a dedicated blog post. I would like to thank all our attendees who took out time of their busy schedule to be a part of this webinar. Thank you so much, Marco and Paul, for such insightful answers. To conclude the webinar, I'll again like to thank Marco and Paul for joining us in the session. We have really learned a lot about the future of LoRaWAN in agriculture. Also, thank you, Harita and Pritha, for sharing your insights about the trends in adoption of LoRaWAN technology in agriculture. We have got an overwhelming response through registrations and questions that were put across during the webinar. With this, I would conclude today's webinar. Thank you everyone who attended, and I wish you all a wonderful week ahead. Thank you so much.
Thank you. Bye-bye.